It's interesting what I have to do to make sure this class works remotely. I have to log on twice onto the WebEx, one from my laptop where I'm showing the presentation and one from the computer in here because that's the computer that has the camera. So let's see up here, we have a little video that's coming from the one computer while the presentation is coming from the other computer. And then these microphones up top are connected to this computer also. So all of the production is on this computer and all of the presentation is on the other computers. So every room, I have to do this a little bit differently. So this is the one room where I have to use two computers. But anyway, let's get back into our materials. I'm going to continue a little bit with our relational algebra and our tables here because I want to make sure that this part is clear before we go on to the SQL. You know, the SQL is going to be the majority of our course. We're going to do a couple of weeks worth of learning SQL and learning the different commands in SQL and the different syntaxes. But before we do that, I want to make sure we're clear on the relational concepts. So, you know, once again, we have this table. The main reason for this table is it provides a very nice mechanism for cutting and pasting symbols. And that's what I did for the questions that we've already done. So we're going to review those. And then we're going to do a couple of additional questions just to make sure that we've got all these relational concepts down. But let me go to the next slide. So, you know, for those of you who are doing the Netflix tables or who have already done the Netflix tables and you know, I've reviewed the tables and given you rate. One thing I want to point out about this recipe set of tables is that, you know, other than the foreign keys, which are necessary to relate one relation to another, that's a lot of relates. Other than the foreign keys, there are no fields that are repeated across multiple relations in the schema. You know, so for example, an ingredient name only appears once, right? It's only an ingredient. Because if we had it in multiple places, it would be an opportunity for it to get updated or changed one place and not get updated the other place. So generally speaking, when you design these tables for the recipe database or for Netflix or anything else, you don't want to have something that is repeated in multiple places that can get out of sync. You know, the only thing that should be repeated is any foreign keys that relate two tables together. Okay, does that make sense to everybody? Do you understand that? It's both from a storage perspective and from a consistency perspective. Repeating stuff in multiple tables is not a good idea. The other thing is if you have a table, let's say I separated grocery inventory. You know, I separated that into store name and ingredient ID and section name. And then I had another table that said store name, ingredient ID, and then aisle number, quantity, and ounces per package. You know, if there's a one-to-one correspondence between the tuples or records in one table and the tuples or records in another table, then you have to ask yourself the question of why there are two tables rather than one. Does that make sense to everybody? So generally, you know, if you have a one-to-one correspondence between records in one table and records in another table, you have to ask yourself whether it would be worthwhile to combine those tables. So the reason I mention that is for the Netflix tables that I graded so far, those were the two most common mistakes. Okay, one of them was that you had a field that would appear in multiple tables and have an opportunity to get out of sync. And I commented on those accordingly. And number two is that you had some tables that were just essentially one table split across two tables. Okay, so if you saw that error, that's where you might have lost some credit on that assignment. And that's an important thing to keep in mind as you design these databases. And we're going to talk about database normalization later in the class, later in the course. And that will really define, you know, how you line up these tables. But it's good to think about the tables. It's good to think about the relationships between them because, those things help you understand how to structure these things. And the Netflix tables are due by the end of today. So I'm not going to go over that assignment today. I'm going to wait till our next class to go over that assignment. And we're going to talk quite a bit in our next class about what a Netflix data model might look like. Okay. The one other thing I'm going to say relative to your homeworks, and I give this advice to all my classes, is it is great to start your homework as early as possible because then you find out what might be giving you problems. And if you have problems, you can come to me and ask me, and I can give you clarification. So it's great to start your homework as early as possible. The advice I'll give you is start it as early as possible, but hand it in as late as possible. Because if you wait to hand it in, you might find out something that helps you do it better at the end. Okay. So my advice for doing homework, not just for this class, but for all your classes, is start early so you know what problems you're going to run into. And wait to turn it in because you might learn something in a subsequent class that might help you with your homework. Make sense? That's one of my recipes for success on homework. All right, so this is our database schema. I'll refresh your memory on this. We have recipes that refer to recipe items. And the recipe items are specific or point to specific ingredients that are part of that recipe. And the ingredient information includes the name and description. The recipe item says how many ounces are being used in that particular recipe. And, the thing I want to point out about these tables is, the same ingredient might be used in multiple different recipes in different quantities. So that's why we have the separation between ingredient and recipe item, right? So that we're not repeating the ingredient name and description for every recipe in which that ingredient appears. So let's look at the problems that we already did. Okay, so the parts of the database, we had this question, what are the relations in this database? What is a good candidate key for each relation? What are the foreign keys? And give an example of what each thing would look like. So you guys did a good job on this. You knew that the four relations are recipe, recipe item, ingredient, grocery, inventory. And a candidate key for each relation, I show recipe ID for recipe. For recipe item, we need both the recipe ID and the ingredient ID to identify it. For ingredient, we just need ingredient ID. And for grocery inventory, we need at least the store name and the ingredient ID. And, if we have multiple quantities of that ingredient, different ounces per package for different packages, we might need that as part of the key. And, if we had a brand field, if we sold multiple brands of the same ingredient, we might need a brand ID as one of the keys in that field as well. But, for the purposes of this thing, the things that are in bold are the things that are the keys. Okay, the next question, what were the foreign keys in each relationship? And, recipe item had a recipe ID that referred to a recipe. And that corresponded to the contains relationship on the previous diagram. Recipe item had an ingredient ID that referenced ingredient, and that was the specifies relationship on the previous diagram. And grocery inventory had an ingredient ID which referenced the ingredient also. And that was the is found at relation. So, those corresponded to each of these relationships that were on the diagram that we have on the original chart. All right, so the first problem we had was to find the name of the store, the name of the ingredient, and the quantity on hand, and the total number of ounces on hand for each ingredient. So, we did first we did our join on the ingredient ID between grocery item and ingredient. And then we did a project on that for the four things that we were looking for. And one of those things was a formula, essentially. And that formula was, we had to multiply the quantity by the number of ounces per package to get the number of ounces on hand, the total number of ounces on hand. Everybody remember that? Does anybody have any questions on that? This is the way it would look in a Word document or a PowerPoint slide or an Excel file or whatever you need to put these things in. I cut and pasted all of these symbols from that table that we had on the previous slide. So when you have to do this for your homework or for a test, you know, it'll look something like this. The other thing I want to point out is that when I did this, I indented to make things a little bit clearer, you know, to make it more readable. So, you know, the joint is indented separately from the project, and that makes it a little bit more readable. So when you do these things, you know, try to make it readable. It's almost like a program, you know, it's, you guys do this for programming all the time. You have your braces and things like that for C, or you have your parentheses for Java. So think about this almost as writing a program, and you want to make sure that you get proper indenting to make it readable. Question number 2, this is the one where I messed up a little bit, so I'm going to fix it today. Question number 2 was to find the names of all recipes that use both tomatoes and onions as an ingredient. Now, one of the solutions we gave was correct. We took the union of those things that use tomatoes as an ingredient with the union of those things that took onions as an ingredient. And to get each one of those, we had to join recipe with recipe item with ingredient. So these statements are the same, except for the fact that this says the ingredient name is tomatoes, and this says that the ingredient name is onions. So since they are the same and return the same field, recipe name, we can do a union of those two to get those things that have both tomato, sorry, that's wrong. That's wrong. There should be an intersection. Sorry, that should be an intersection. My bad. Remember, intersection is or. So, I mean, intersection is, oh no, I'm sorry, it is and. Yeah, I'm sorry, it is and. It has both tomatoes and onions, so it needs to have an intersection. Sorry about that. Grab that symbol. There we go, that should be. So that's it. It has both tomatoes and onions. So that is an intersection. It's those recipes that have tomatoes intersected with those recipes that have onions. And that gives us the correct result. Okay, so that was the answer to the second question. And I did something incorrect. So I'm going to correct it now. I said that this was a replacement for that statement. It's not. You can't have two values for the value ingredient name. You know, you can only have one value out of that joint. So to correct this statement, what I did was I assigned a select where the ingredient name was onions, and I called that onions. You know, I assigned that to onions. I did a select where the ingredient name is tomatoes, and I assigned that to tomatoes. And then I joined onions and tomatoes where the recipe ID was the same. So if they're in the same recipe and they have onions and they have tomatoes, then that's the recipe that we want. So this corrects the incorrect statement that we had last time. So I wanted to make sure to review that with you because we can use this statement in place of the intersection that we showed earlier, but we need the two separate statements and we need to join them in recipe ID. Does anybody have any questions on that? So this statement with the intersection is equivalent to this statement here. So either one of those is correct for this problem. All right, let's look at the last problem. The last problem was to find the names of all recipes that use ingredients sold in the produce section of ShopRite. So the store name has to be ShopRite and the section name has to be produce. So once again, this upside down thing is the end. And what we're doing is we're projecting recipe name. We're joining recipe and recipe item and ingredient and grocery item all together on their key fields, their foreign and primary key field. And that gets us our answer to question number 3. And these slides will be up on the on Canvas at the end of this lecture. So these will replace the slides, so you'll have the answers recorded. Does anybody have any questions on these? All right, if not, let's go on to question number 4. Put this in slideshow mode. That's not good. That's good. All right, so question number 4 is to find the names of the recipes. I need my marker. Find the names of the recipes, the ingredients and ounces, and the sections and aisles of Stop and Shop that would need to be visited to shop for them for all recipes that produce more than 20 servings. All right, so what's the first question we need to ask? Who remembers the process here? Yeah, Michael.
First few things you gotta join together.
Yeah, you got to know what tables you're going to have to join or what relations you're going to have to join together. So who can tell me what relations we need to answer this question? Go back to the should see that. Yeah. Okay, so which relations do we need to join together to find out what recipe name or what the recipe names are, or what was the question? Names of the recipes, ingredients, and ounces in the sections and aisles of Stop and Shop for all recipes that require that produce more than 20 servings. Do we need recipe? Yeah. Yeah, we need recipe because we need to know the recipe name. And we need to know the number of servings, right? Do we need recipe item? Well, we need to know Stop and Shop. You know, we need to know the stores, the Stop and Shop. So we need grocery item, and we know we need recipe because we need the recipe name. So the only way we can connect recipe to grocery item is to have which relations? All of them, right? So we need recipe item. We need ingredient. And we need grocery inventory. So the first thing that we have to do for this problem is we have to join all these things together, right? So let's join all these things together. And there are various orders we can do them in, but I like going in order. We'll do recipe. And we'll join that recipe item. What's the predicate I need here? What's the condition for that join? Anybody remember how those two tables are related? Yeah.
Recipe ID and recipe ID.
That's right. So we need recipe, not recipe ID. Equal recipe item, not recipe ID. That's the first joint. And we've got the next joint, which is ingredient. Okay, who can tell me the predicate for that? The condition?
The ingredient ID.
That's right. So here we need recipe item dot ingredient ID. Equals ingredient. Dot ingredient ID. And you'll notice, these are all our primary and foreign keys that connect these tables. That's how we know what these predicates are. And then we've got the last one, which is
What's
grocery item.
that recipe item?
Sorry?
Oh, no, I was just asking if I is recipe item.
Recipe item. Why is it recipe item?
No, I'm saying, is that what that stands for?
Yeah, RI stands for recipe item. I'm sorry, I'm abbreviating this in the interest of writing these things. All right, so what's this last condition? Yeah, that's right. Exactly. So we would take ingredient. Dot ingredient ID. Equals grocery item. I'm going to abbreviate GI. Dot ingredient ID. Okay, so we've done our joins. And so we can put these in parentheses. All right, what do we need to do next? Yeah,
Select.
okay, great. Yeah, what are the conditions for the select? Says for the sections and aisles of Stop and Shop that would need to be visited to shop for them for all recipes that produce more than 20 servings. So there are a couple of conditions here. Does anybody know what one of those conditions might be?
Select.
Yeah, what's the condition for the select?
So the store name has to be ShopRite.
Exactly, the store name has to be Stop and Shop. Because we only want those records that have to do with Stop and Shop. Okay, is there another condition here? We want the recipes that produce more than 20 servings. That's the other condition that we're trying to meet here. So in addition to the store name being Stop and Shop that comes out of this, we want an and. And again, ands are always upside down, so ors are right side up. We want an and here. On the servings. And if we look at the table, let me make sure I got the right name for it. Yeah, you'll see servings is in recipe. So the number of servings that the recipe produces is in recipe. And what is that condition that we want on servings?
Serving is greater than 20.
Servings greater than 20. Exactly right. Okay, so that's the second thing, and we can, that's our open parentheses for the join, and we'll close our parentheses here. We already closed our parentheses. All right, so we've got that. Anything else we need to do?
Project all the items they want to be done.
Yeah, we do our project. Exactly right. Okay, and the project. What fields do we want as part of the project? What are they called? Just go down our bullet list. Yeah.
Recipe name.
Recipe name, right?
Ingredient. Which one?
Ingredient name.
Ounces. I guess file number and section name.
Section name and aisle number. That's right. Okay. So, when we're writing these fields, we're not saying what table they come from. We're not saying recipe name or ingredient name and things like that. That's because these names are unique in our tables. If these names were not unique in our tables, if we had that same value elsewhere, for example, if we wanted the recipe ID in this list, I'm sorry, the ingredient ID in this list, we couldn't just put ingredient ID. Because ingredient ID appears in multiple relations in our schema. In one of the relations, an ingredient, it's a primary key. And in the other relations, grocery item and recipe item, it's a foreign key. So when we do these projects, if we have a field, I'll get to you in just one second, Michael. If we have a field that has the same name in multiple relations, we do need to explicitly put which one we want there. Does that make sense? Does everybody understand that? Can you say that again? Yeah, so if we wanted the ingredient ID in this list, if we wanted to return the ingredient ID, since ingredient ID appears in multiple relations, as either a foreign key or a primary key, we can't just say we want the ingredient ID because we have to say which relation is going to provide the ingredient ID. Okay, so in this case, we would have to explicitly say ingredient ID to say that the value of ingredient ID that we want is the one from the ingredient relation. Make sense? Okay, and sure enough, here's the answer. The same answer that we came up with. And you'll notice, for example, I have the conditions in a different order. I have, servings greater than 20 and store name equals Stop and Shop. Different order, but, since that's an and, order doesn't really matter. That's a transitive operator. And is a transitive operator, so you could put those in either order. Store name, Stop and Shop, and servings greater than 20. So, this is the same formula that we came up with in our little exercise here. All right, we're going to do two more of these. And this one, what I'm going to ask you to do is I'm going to ask you all to take your time and to do this at your desks. Yes, Hannah?
I just have a question. How do you know which ounces it's referring to? It's not very specific about which one.
Yeah, so this word ounces, we have two fields here that could have been mentioned. We have ounces in recipe item and we have ounces per package. So in this particular case, the words say number of ounces and was referring to the ounces in the recipe item in the word thing. But if we call these two fields the same thing, if both were called ounces, we would have had to say the name of the table dot ounces. Now, we can say, for example, that the language, there we go. You can say that the language here might have been imprecise. It wasn't clear whether it meant ounces or ounces per package. Yeah, I mean, that's fair. If you get a specification like this from a customer, for example, and the customer says, this is what I want, it's perfectly reasonable to go back to the customer and say,
The way it's listed is with the ingredient rather than with the recipe.
right. I mean, you can infer from that. But if there is any lack of clarity, where you get into these situations where people are asking, or where you're doing a design of these things and people are asking for certain information, it's perfectly reasonable to ask for clarification from your customer. And actually that's part of the requirements and design process for these databases. That's why I mentioned this. We go through this process. And I don't know, some of you know, I know some of you are taking both my security course and my database course. So some of you know I also teach security. And this is a very important idea in security, is that anything that is different from what the customer really wants can be a flaw in your program and can be something that can be exploited. Okay? So until they invent that helmet that you can put on your customer that translates exactly what they're thinking into code, any point in the design process is an opportunity to introduce error. You can get the customer requirements wrong, you can get the design wrong, etc. So, one of the things I like about teaching database is we teach that process that I showed you, where we go from the requirements, the business rules, to the data required, to the the entity relationship diagram design, to the logical schema. It's a very step-by-step process. And as you go through each of those steps, you can go through a validation phase at those steps so that you catch those errors up front, rather than having to get all the way to the end of the implementation and find that you have those errors then. So, English is the language that we use to state the requirements. We're translating that English into a more formal language that really captures what those requirements mean. It really specifies explicitly. When I read that statement, I know exactly what that statement is asking for. Okay? And, that helps me nail down the design. If I cannot write that statement based on what I see from my customer, I have to go back to my customer and say, what did you really mean by this? Okay. What we're going to do in our next class is we're going to find out how we then take this into a SQL program. So I like the question that you asked, Hannah, because it shows the merits of this design process. We had to do some interpretation of this to produce this design, the specification. Once we have the specification, how to turn this into a program is pretty explicit. So good question, and I like the question because it really helps to understand this design process in better detail. So there's our question 4 answer. And now we're going to do question 5. You guys are going to do this on your own a little bit. I'm going to give you some time to do it. And then we'll go through the answers. So take some time and do this exercise. I want to make sure, I don't call on anybody for answers. I take volunteers, but you should be able to know in your own mind whether you've got the hang of this or not. And this is an opportunity to test that. So, try to do this next question on your own before we do this in class. And I'll give you about, let's say about 5 minutes to do this one. This one's got a little tricky something in it that we haven't seen yet. Do I need more time? Need more time? Raise your hand. Okay, I never call on anybody, but is there somebody who hasn't answered a question previously who wants to tell me what relations we need to answer this query, to answer this question? Yeah, Mike.
Could be recipes, recipe of human being.
Recipe, item, and ingredient. Yeah, we certainly need those three. Do we need grocery inventory?
Yes.
Yeah, we need grocery inventory also because we need the names of the stores and we need the aisle numbers. So we need to include that one also. So our join for this one is, pretty much the same as the join for last one. So, I'm going to erase this. And the relationships between these tables is pretty consistent. I mean, it doesn't really change. So the things that we're joining on are generally the same also. Now, the one important point I want to make about that, and we'll get into this as we go down the road, is that there might be more than one relationship between two relations. You guys are students and I'm a professor, right? I have the relationship with you that I teach you, right? That's one relationship. Some of you are unfortunate enough, in addition to having me as a teacher, to have me as an advisor. So, you might have, there's a second relationship that's possible between the student and the teacher relation, where teacher advises student. So, there might be a advisees table that has a teacher ID and a student ID that relate us as advisees. There might also be a teachers table or teachers relation that says teacher ID, student ID, teacher teaches student. So the important thing to remember is that, there might be different predicates that we have on these joins in the future if we have multiple relationships between two relations. But for the purpose of this exercise, we only have one. Our diagram is simple. The diagram is simple. There's only one line between each of these two boxes. Okay. So we only have one set of things that we can join these things on, and that's what we do for this question number 5. Okay. So we've done our joints. We got a shortcut on our joints by virtue of having done the last question. Does somebody who doesn't generally answer questions want to take a cut at what we do next? Anybody have any thoughts? Any ideas? What do we generally do next year?
Do we do select?
We'll do the select. Let's do our select, which I do very nicely this time. And what do we want? What are the conditions that we want? What are the conditions that we want the records to meet that we return from this question? Yeah.
It has to have enough of certain ingredients, so like the quantity has to be a certain amount.
Yeah, we have to have a certain quantity here. And when we talked about a previous question, we had a previous question that said number of ounces on hand. And we did a calculation to find out how many ounces we had on hand. But we also have something that tells us how many ounces we need. So there's something we have to do about number of ounces and number of ounces on hand to tell us which grocery stores, which grocery might have enough, right? Does anybody have an idea what that condition might be? Yeah.
Multiply the quantity that's in the grocery store by the ounces per package to find out how much they have to store.
Yeah, so we know that if we multiply the quantity by the ounces per package, and I'm going to abbreviate that oz per package, but you guys know what I'm referring to. All right, ounces is, I'll write it out. It's not much harder. We'll multiply that by ounces per package. That tells us how many ounces the grocery store has on hand. What do we need to compare that to? Zach, you had to hand up?
The amount of ounces that you need for So be greater than or equal to that?
Yeah, that's exactly right, greater than or equal to ounces. So that's one question, one condition for the select, yeah. You guys got it. Is there any, gosh. That happened. There we go. You all didn't see that. All right, what's the other condition we need to put here? Or is there another condition we need to put here? Like,
Would it be, what's it called? You guys, ingredient name equals basil?
yeah, and ingredient name equals basil. That's another one, yep. Do we need any other condition here? Yes, sir. Equal. And, yes, and recipe name. Equals meatball. There we go. So that's our select. Yeah, all right. And what's our project here? Yeah,
The store names and the aisle numbers.
yep. Okay. Store name. Close branding, close branding. There we go. Right there. There we go. All right, so that's our number 5. By the way, you know, the reason I'm doing these extra ones or so many of these is I want to make sure that we all have this. You know, I know, you know, a number of you, some of you are answering multiple questions here. I want to make sure that everybody is reasonably comfortable with this, and hopefully this will do it. But, you know, here's the result. And once again, these conditions for the select can be in any order. But we got the recipe name, ingredient name, ounces, section name, and aisle number. Let me make sure I didn't add too much here. Yeah, actually, yeah, we just asked for the section name and aisle number, so yeah, these shouldn't be here. Okay, the recipe name is meatballs, the ingredient name is basil, the quantity times ounces per package is greater than or equal to the ounces, just like that. And we have all those same joins that we had previously. So that is the answer to question number 5. And we've got one last question. I promise you this is the last one until you have to do your homework. And this one is a little hard. Let me put it on full screen here so you can see it. And I'm going to give you some time to work this one also. We want to find the names of all ingredients that are either in the lasagna recipe or in the manicotti recipe. So you guys take some time to work on that. We want all. Name of all ingredients that are in both, or in either, rather, the lasagna recipe or the manicotti recipe. I like to use manicotti because my wife's absolute favorite food in the world is manicotti. So, question if she uses the word manicotti. All right, so let's work on that a little bit. This one looks easy, but it's actually hard. Does anybody need more time on this? Yep, more time. You don't generally need to. Yeah, the one thing you've got, your joints are right. Just have it in your thing. Okay. And you've got the right way to put them together. Okay. Yeah. Everybody good? All right. So we see a problem like this. And we can kind of break it down. Now, we can write an expression that gives the ingredients for a given recipe. So how would we write the expression, that gives the ingredients, for example, for the lasagna recipe? What would we write for that expression? First of all, what relations would we need to say what's in the lasagna recipe? We need recipe because we need to know which is the lasagna recipe, right? And what tells us what's in the lasagna recipe? Yeah, we need both recipe item and ingredient. That's exactly right. Is there anything in this question that would require us to know the grocery inventory?
No.
No. So it's just these three. All right, so let's join these three together and see what happens. See? And I'm not going to ask you what to join them on because by this time, this is pretty old hat. It's recipe ID. I'm sorry, recipe ID, yeah. We agree on recipe ID. And then we need to join that together with ingredient. And here, recipe item dot ingredient ID. Ingredient. Okay, so that gives us all the recipes and all the, all the ingredients and all the recipes. How do we find out what ingredients are in the lasagna recipe? Just the lasagna recipe. Yeah, Michael.
Would you do,
It's select, wait,
wouldn't select recipe name equals lasagna?
That's exactly right. Equals. Done. Okay, so that gives us all of the information about recipes that are, or about ingredients that are in the recipe lasagna. So from here, we can do two things, one of two things. Does anybody have a suggestion on what to do next? Yeah.
You join it with the same thing, but for manicotti.
So you join it, when you join it?
Union, I meant.
Oh, union.
Union.
Yeah, union. That's exactly right. Yeah, we could do this same expression again, exactly the same expression. Only instead of selecting based on recipe name equals lasagna, we select based on recipe name equals manicotti. And then we repeat this whole expression again under that. That's exactly right. So that gives us, remember the union is the thing that we use when we're doing either or. So that's exactly right. It's either in manicotti or it's in It's either in lasagna or it's in manicotti, so we use a union to get all of the things that are in one or the other. And now what do we do? Yeah, we need a project in here. And what do we want in this project? We need this whole expression in the project. Both pieces. We just want the names of the ingredients. And we'll do ingredient name here. Okay. Is there any other way we could have done this other than this? Yeah.
Selection, could you use the downward symbol for the or and just put recipe name equals lasagna or recipe name equals?
Yeah, we could have done that. We could have put an or there and said recipe name equals lasagna or recipe name equals manicotti.
I thought we weren't supposed to do that.
No, you can't do it for a union because a union, it would have two values for the recipe name. But for an or you can because it's either that value or the other value.
So would that get rid of the union if you did the or?
Yeah, if you did the or, you could get rid of the union. The other thing we could have done is we could have done our project on this first expression and then did the union of that project on the second expression as well. So we could use the same expression, including a project, and union those together, because as long as you have the same field coming out, in this case, it would have been the ingredient name, you can union those two sets. Yeah, Michael?
Why didn't you put ingredient name on after the union?
Why didn't I put, what?
Like, why didn't you write that again?
Oh, I just ran out of board space.
Oh, okay.
That's all.
I didn't know if you were supposed to.
No, you have to write it again. I just ran out of board space, but you'll notice that when I did it here, I did do that.
Okay.
Okay. And in this case, I did the project 2 times. You know, I did it once for the first expression and once for the second expression, and then I unioned them. By the way, thanks a lot for Professor Weiss, because I did not close my parentheses. There we go. That's correct. There we go. So I put my project in both places. You know, didn't have to do that. I could have just as well. There we go. All right, so if I wanted to, I could have just as well had left off this project. So this is a correct answer as well. That's the one we came up with in class. And the other answer that would have been correct would have been just to say recipe name is lasagna. Or and then I could have left off all of this. So all of those expressions are equivalent. Okay? So any one of those would have been acceptable for this this problem. I'm gonna leave it the way I had it. It's- Yep. Okay. There we go. All right, so that any of those expressions is equivalent. Any questions on this one? This one was the hardest one we've done, and I promise you, oh, there it is. I already did it. Yeah, so there's the other one. Is this right? Yes, this is right too.
So if we use the or instead of the union, wouldn't that display any ingredient that is used in lasagna and manicotti instead of the only the ingredients they use in both?
So, yeah, remember this question was any ingredient that is either in lasagna or in manicotti.
It says used in both lasagna and manicotti, so that's the ingredients that are shared.
Number 6, are you looking at the same one?
It says it differently on the slides that
Oh,
were.
yeah, if you downloaded the slides, I might not have updated it on the slides, but I wanted to do.
Or say both.
It says and on the.
Yeah, that's why I changed it for the presentation. I'm sorry, I shouldn't have uploaded that version of the slides before this class, because I wanted to do this one is either in the lasagna recipe or in the manicotti recipe.
What is still union?
Sorry?
Either way. It goes and or.
So the one I did in class was either the lasagna recipe or the manicotti recipe. The one that was out on the canvas had and, so that might.
Or like, would we still use the union symbol? Those?
If it's an and, you're using the intersection symbol.
Okay.
So yeah, so hopefully I haven't confused that too much for you. Let me write it explicitly just so you all know. If you have something that is in set A and set B, it's A intersection B. That means it's in set A. Those things that are in set A that are common to those things that are in set B. So this means A and B. If you have something that is in set A or in set B, then it is A union B. That's everything in set A and everything in set, along with everything in set B. Okay. All right, that's it for question 6. Oh, we're coming up on our time. All right, so you guys are going to have more practice with this stuff. You will see your next assignment in Canvas. Is right over here. This is due. Let's say you have a little extra time for it, September 30th. All right, but you'll see that. Oh, I'm going to, actually, no, I want to make this a week from today. So we're going to do these relational algebra. Oh, there they are. Relational model exercises. Like that. So you will see something here. Make this due September 28th. I guess I get 2 extra days for it. That's fine. All right. So, here we have a database. It has entertainments. It has reviewers. It has reviews. It has talents and it has credits. And you'll see the questions here. You'll have to say which are the foreign keys and primary and foreign keys for each relation. You'll have to write 3 relational algebra expressions and add at least one relation to this database and describe and write a relational algebra expression that includes the relation you added and at least one other relation that already exists. So you can use the relational operators document to cut and paste the symbols that you need. But this is your assignment for a week and a half from today. Okay, and the last thing I want to do before I let you go is I want to show you the database that we're going to be working with to learn SQL. This is the logical view of that database. You know, we're going to start off with this database. This is one of the databases I use. But we have a table that has student data. It has ID, last name, first name, their gender, and their class. You know, what class they're in. It has a grade that they received for a graded item. You know, there are some number of graded items for which, you know, homeworks and things like that for which they received grades. So they have a record of the grade that they received for graded items. And there's a table of what those graded items are, you know, what the homework assignments were that they got graded on. And the grades are taken from a grade range that includes a minimum grade, a maximum grade corresponding to a letter grade. Okay, and those students are enrolled in a specific class where the class has a day, the days the class meets, the start time and the end time. So this is the database that we're going to work on when we do our SQL queries. And I've populated a database that looks like this with some phony student data, and we're going to do our SQL queries against this to understand the grades that these students received. So we're going to do that starting our next class, and we're going to use that as our basis for doing our SQL examples. Okay. And that wraps it up for today. Does anybody have any questions or comments? Okay. Hopefully you guys will have the hang of this, and we'll see from the homework assignment. Thanks a lot. Everybody have a great day, and we'll see you on Thursday.
Hi, have a good day, Professor.
Oh, that, I wanted to ask you about the cybersecurity